Okay, in section 6.3, we talked about how we can add and subtract polynomials. Well, in our next section, section 6.4, what we're going to be taking a look at is, of course, when we want to now multiply polynomials. After all, polynomials are just basically unknown numbers, okay? They're made up of variables and numbers. And just like when you learn any type of number system, you always learned how to perform the four basic operations. First, when you learned the whole numbers, you learned how to add, subtract, multiply, and divide. Then when you were introduced to fractions and decimals, those number systems, you learned how to add, subtract, multiply, and divide. Then you learned about integers. Those, of course, were the sign numbers. You learned how to add, subtract, multiply, and divide. And the same is true with these algebraic numbers, polynomials. You're going to be taking a look at how to add, subtract, and now multiply these polynomials. Well, the first thing that we're going to do is if we're going to multiply a polynomial with what we call a monomial. Okay, for example, if we have 5 times 3x squared minus 7x plus 1, okay, here we are multiplying the polynomial, what's inside the parenthesis, with the monomial, the number 5. And so, of course, what we have to do is that distribution property that we're familiar with. We have to distribute the 5 on all 3 terms. Because whenever we're involving multiplication, involving polynomials, we're basically going to be using a lot of distribution. Okay? That's your basic underlying idea. And when we distribute the 5 on those 3 terms, 5 times the 3 would, of course, give us a 15x squared. 5 times the negative 7x would give us a negative 35x. And 5 times the 1 would, of course, give us a plus 5. And that would be your simplified expression because we have eliminated the operation of multiplication. If we can multiply by a number, we, of course, can multiply by a variable as well. For example, if I was to take x to the 4th times maybe 5x squared plus 8x plus 2, and once again, I am multiplying the polynomial with a monomial of x to the 4th. Now I would have to go and use the distribution property and distribute the x to the 4th on all of our terms. But we have to keep in mind here now that law of exponents, that when I am multiplying the variable, we have to add the powers. Okay, so don't forget, a to the m times a to the n equals a to the m plus n from the beginning of chapter 6. So when we multiply the x to the 4th with the 5x squared, that would give us a 5x to the 6th. Because remember, we have to add the 4 and the 2 to get the 6. If I was to multiply the x to the 4th with the 8x to the 1st, that, of course, would give us an 8x to the 5th. Plus, x to the 4th times 2 is simply a 2x to the 4th. And that would be your simplified expression because we eliminated the multiplication. Now, in the first example, the monomial was just a number. The second example, the monomial was a variable expression. But we can also multiply a polynomial, like let's say 4x squared minus 8x plus 5, with a different monomial made up of numbers and variables. For example, I could multiply it by a, let's say, 2x cubed. And once again, what we need to do is to distribute that monomial of 2x to the 3rd on all 3 terms. And so now when we do that, of course, 2 times 4 would give us an 8. And when we multiply the x cubed and the x squared, that would give us an x to the fifth. 2x to the third times a negative 8x would give us a negative 16, and we would have an x to the fourth. And 2x to the third times the 5, the last term, would give us a plus 10x to the third. And that would be your simplified expression. Okay? We have performed the multiplication here of a polynomial with a monomial. Now, another idea is, of course, to multiply a polynomial with another polynomial. Now, a lot of times when people think of this, the word FOIL comes to mind. Okay, now FOIL, much like PEMDAS, okay, you may have heard that expression as well. PEMDAS is an abbreviation that we use to help people remember the order of operations. Well, FOIL is another word that we use to help people remember an order in which we multiply a polynomial with another polynomial. Now, when we use that word FOIL, it's because we're talking about the first, the outer, the inner, and the last terms. Okay? That's what that word FOIL is used for. It's just an abbreviation that we use to help students remember the order in which you are performing. Basically, once again, it's just the distribution property. For example, let's multiply x plus 5 times x plus 3. Okay? Now, when we are multiplying here, we're multiplying a polynomial with another polynomial. Basically, what you're going to do is you're going to multiply the x with the x. That's considered the first term. And x times x would give you x squared. Then you have to multiply the x with the 3. Okay? That's considered the outer term. And x times 3 would give you a plus 3x. Now, you can't multiply the x with anything else. You have exhausted multiplication of the x with all the other terms in the other polynomial. So now we go to the next number, the number 5. And I have to multiply now the 5 with the x. Those are considered the inner terms, so 5 times x would be a plus 5x. Then we have to multiply the 5 with the 3, because those are considered the last terms. And 5 times 3, of course, would give us a plus 15. We're not done with the problem. As always, they want you to express your answer and simplify as much as possible. And we have like terms here. The two terms in the middle, 3x plus 5x, those are like terms. So we're not going to do anything with the x squared. However, the 3x plus the 5x, that would give us an 8x plus 15, and that would be your simplified expression. So that's how we multiply a polynomial with another polynomial. Okay, you're basically using the distribution property. Like I said, some people say that you are foiling these, okay, but foiling is really a made-up term that students use to help them remember the order in which you have to multiply and distribute. Let's just try a few others. Let's take maybe x minus 3 times x minus 9. I'm going to multiply x times x. That, of course, would give us x squared. X also has to get multiplied with the negative 9, and that would give us a negative 9x. I can't multiply the x with anything else, so now I have to go and multiply the negative 3 times the x. That would give us a negative 3x. and then negative 3 times the negative 9 would give us a plus 27. Watch your signs. Simplify as always by combining in any and all like terms, and right here in the middle we have some like terms. So we would keep the x squared. The negative 9 minus 3 would give us a negative 12x plus 27, and that would be your simplified expression. You have performed any and all operations. You multiplied and you combined like terms. Let's try another one. Let's say we have maybe x minus 7 times an x plus 2. We want to multiply. I'm going to start by multiplying, of course, x times x. That would give us x squared. X times the 2. That would give you a plus 2x. Next, I have to multiply the negative 7 times the x. That would give you a negative 7x. And then negative 7 times the 2. That would give you, of course, a negative 14. Combining like terms, right here in the middle, once again now we would have x squared. 2 minus 7 would give you a negative 5x minus 14. And that would be your simplified expression. Let's have you one to do one. Let's say we have the following. X plus 5 times x minus 5. Pause the video, multiply those two polynomials together, and let's see what you get. Turn it back on when you're done. Performing this multiplication, I would begin by multiplying x with x, and that of course would give us an x squared. X times the negative 5 is a negative 5x. 5 times x would be a plus 5x, and 5 times the negative 5 is a minus 25. I notice here in the middle we have like terms, and so when I combine them, I get x squared. Negative 5 plus 5, that's 0x. Not even going to bother writing it. Minus 25. And that would be your simplified expression. Let's try a few others. Let's say we have 2x plus 5 times a 3x minus, let's say, 7. Let's multiply these together. Be careful of your signs and your numbers. First, I multiply the 2x times the 3x. That would give us a 6x squared. 2x times the negative 7, that would give you a negative 14x. Now let's multiply 5 times the 3x. That would give you a plus 15x. And then 5 times the negative 7, that would give you a negative 35. If we have like terms, we should combine them, and we do, right here in the middle. We will keep the 6x squared. Negative 14x plus 15x would give you a plus 1x minus 35. Try this one. Let's say we have x plus 4 squared. I'd like you to pause the video now and try this one. I am very curious to see if any of you are going to make the common mistake that many students do, okay? So, pause the video, try this particular problem, and let's see what you get. Well, if I was going to make this a multiple choice question, okay, and I wanted to trick some of you, I would put down as answer choice A, as x squared plus 16. Okay, that's the common wrong answer. Many times when students see this particular problem, okay, they think, well, gee, x plus 4 is being squared, so let me square the x, which is the x squared, and let me square the 4, which would give me the 16. But this is incorrect, okay, and then you would have gotten that question wrong, okay, because what you were doing is you recalled from your laws of exponents that a times b to the m power equals a to the m times b to the m. And why can't I use this law of exponents on this particular problem? Well, if you look carefully, you'll notice that the law of exponents here that you tried to use is the distribution of a power over multiplication. The a and the b are being multiplied. Here, for this particular problem, you cannot use this law because the x and the 4 are not being multiplied. They're being added. And you cannot, okay, distribute an exponent over addition or even over subtraction for that matter, okay? So this is the common wrong answer. Okay, like I said, if I was going to make this a multiple choice question, I would put this down as answer choice A and fool some of you into getting it wrong. But instead, what we want to remember is, what does it mean when we square a quantity? Okay, like the number 5 squared is 5 times 5. Or the number 8 squared is 8 times 8. So if I have x plus 4 squared, that is the same thing as x plus 4 times x plus 4. So we want to write it twice because we are multiplying it by itself. And now it becomes a problem similar to what we were doing previously, in that we would have to multiply x times x. That would give you an x squared. X times the 4 would give you a plus 4x. Then we have 4 times x. That's another 4x. And then finally 4 times 4 would give you a plus 16. And when you combine the like terms in the middle, what you get is x squared plus 8x plus 16. That is the correct answer. Okay, so hopefully you did not fall for the common mistake. All right, so just be careful of that. Let's try another one. Let's say we have higher exponents than just x. What if we had maybe x to the third minus 5 times x to the third plus 8? Well, once again, we are going to multiply the same way we did prior, in that I have to multiply x to the third times x to the third. That would give you x to the sixth. X to the third times the positive 8 would give you a plus 8x to the third. Now I have to multiply the negative 5 times the x to the third, and that would give you a negative 5x to the third. And lastly, negative 5 times the 8 would give you a negative 40. As we combine like terms, as we always do here in the middle, we're still going to keep the x to the sixth. When we combine the like terms, we would get a plus 3x to the third minus 40, and that would be your simplified expression. Even if we had more variables than just the x. For example, I might have, let's say, x plus 3y times 2x minus, let's say, 5y. Let's take a look at an example like this, what we're going to do. The process is the same, okay? How we approach the problem doesn't change. And then I'm going to multiply x times 2x. That would give you a 2x squared. I have to multiply the x with the negative 5y, and that would give you a negative 5xy. If we encounter more than one variable in a term, it is customary to write them alphabetically. And since x comes before y in the alphabet, we write x first. I cannot multiply the x with anything else, so now I would multiply the 3y times the 2x. That, of course, would give you a plus 6, once again, xy. And then lastly, 3y times the negative 5y would give you a negative 15y squared. Once again, we always try to combine any and all like terms, and we have like terms in the middle. So we still have now the 2x squared. The negative 5xy plus the 6xy would give you a plus 1xy minus 15y squared. And that would be your simplified product of those two polynomials. If we have more than two polynomials, don't be overly concerned. Okay, for example, if we had x plus 1 times x minus 3 times an x minus 2, okay, don't get overly complicated here, all right? Just like when you multiply numbers, okay, if I gave you, let's say, 3 times 4 times 5, we're only going to multiply two numbers at a time, and it doesn't make a difference which two numbers we multiply. I could multiply 3 times 4, that would give you 12 times 5, or simply 60. I could multiply maybe 4 times 5, that would give you 3 times 20, which would also give you 60. I could even multiply 3 times 15, sorry, 3 times 5, that would give you 15 times 4, which would still give you 60. So regardless, you're just going to pick two numbers, multiply them together, and then whatever you get, you would multiply with a third number, okay? And in the end, you always get the same solution. Well, the same is true with when you're multiplying polynomials together, okay? I'm going to take two polynomials and I'm going to multiply them together. I'm going to leave the third one out for the time being. So I'm going to multiply the second and the third one. So I'm going to leave the x plus 1 alone. And now I'm going to multiply. X times x is x squared. X times the negative 2 would give you a negative 2x. Next, I have to multiply the negative 3 with the x. That's a negative 3x. And then lastly, negative 3 times the negative 2 would give you a plus 6. I will combine my like terms just to keep it simple for myself, in which case now I still have the x plus 1, but now I'm going to have x squared minus 5x plus 6. And of course, now what I have to do is I have to go and multiply the x with all three terms of the second polynomial. And so x times x squared would give you an x to the third. X times the negative 5x would give you a negative 5x squared. X times the positive 6 would be a plus 6x. And just like I multiplied the x with all three terms, I now have to multiply the 1 with all three terms. Well, 1 times the x squared would give you a plus 1x squared. 1 times the negative 5x would give you a negative 5x. And 1 times the 6, of course, would give you a plus 6. Always look to see if you could simplify if you have any like terms. Well, x to the third, that's by itself. No like terms there. I have an x squared here and an x squared here. Let me combine them. Negative 5 plus 1 would give you a negative 4x squared. Then we have an x term and an x term. Let's combine those. 6x minus 5x would give you a plus 1x. And of course, then you have the plus 6 at the end. That can't be combined with anything, and that would be your simplified expression. Okay? So if you're multiplying 3 polynomials, it's really no different. Just do 2 at a time. Okay? The last thing that I want to show you is kind of combining today's lesson with yesterday's lesson. For example, what if we had the following? Let's take maybe 3x plus 5 times x plus 1. And with that, I'm going to now subtract x plus 4 times x plus 5. And we want to simplify this as much as possible. Well, there are multiple things going on here. All right. First thing that I'm going to have to do is to multiply the first 2 polynomials, and then I'm going to also have to multiply the second 2 polynomials, because we have to perform multiplication before we can perform this term here, the subtraction. So let's do the multiplication. 3x times the x would give us a 3x squared. 3x times the 1 would give you a plus 3x. 5 times x would give you a plus 5x. And 5 times 1 would give you a plus 5. And I might even be so as to incline this to simplify what I can here in the middle. 3x squared. And if we have the 3x plus 5x, that would give you a plus 8x plus 5. So that is the product that you get when you multiply those 2 polynomials together. And then there's a subtraction sign in between. Next, I have to multiply these 2 polynomials together. And of course, if I multiply x times x, you get an x squared. X times the 5 would give you a plus 5x. 4 times x would give you a plus 4x. And then 4 times the 5 would give you a plus 20. Once again, I might be so inclined as to combine my like terms that I have in the middle, which means I would have an x squared plus 9x plus 20. But now we're only done with the multiplication aspect. Next, we're going to have to combine these 2 polynomials by the operation of subtraction. So once again, like we saw the other day, we have to merely subtract like terms. So if I take my 3x squared and I subtract my 1x squared, that's how we would get a 2x squared. Then let's take our other like terms of the x terms. If I take the 8x and I minus the 9x, that would give me a negative 1x. And then finally we have the 5, and I have to subtract the 20. And 5 minus 20 would give you a negative 15. And that would be your simplified expression. Okay? Not necessarily more difficult, just more steps, more room for some errors, so please do be careful with that. When you have multiple operations, you have to follow the order of operations. That's why we had to multiply first before we can perform our subtraction. Okay? All right. That completes section 6.4 for today. All right, the multiplying of polynomials. Try the homework that goes along with this section, and I look forward to any questions or concerns that you may have. Until the next lesson, be well.